We now want to look at the limits of the form infinity over infinity. What do we mean by this? If you take, let's take example 1, want to find the limit of x squared plus 2x minus 1 divided by 3x squared minus 3x minus 1 as x tends to infinity. Okay, so if you substitute directly, you're going to have infinity squared plus 2 times infinity minus 1 divided by 3 times infinity squared minus 3 times infinity minus 1. Okay, this will result into the form infinity over infinity because we have very, very large value squared multiplied by 2 times very, very large value, an infinite number, and then divided by, so the result will still be infinite, and as well as the denominator it also be infinite. Okay, so to solve this kind of problem, to find the limits of this kind of function, so what we do is we look for the highest value of x in the function. Okay, the highest value of x is, the highest power of x is 2. Okay, so that means we have x squared to be in the highest value. Now we divide each time by the x squared. We divide each time by x squared, so meaning that what we have will be the limit as x tends to infinity, and then we have x squared divided by x squared minus 2x divided by x squared minus 1 divided by 3x squared divided by x squared minus 3x divided by x squared minus 1 divided by x squared. This the constant term ought to be divided by x squared as well. Okay, so by the time we do this, this can be simplified to 1 minus, this one will now become 2 over x minus 1 over x squared divided by 3 minus 3 over x minus 1 over x squared. Okay, so now this ought to be plus. Okay, now this plus. Okay, now we can substitute the infinity. Whatever we see here, we substitute with infinity, so that we have 1 plus 2 over infinity minus 1 over infinity squared divided by 3 minus 3 over infinity minus 1 over infinity squared. Okay, now recall the notes we wrote earlier that a constant divided by infinity will give 0. Okay, so this can be simplified to have 1 plus 0 plus minus 0 over 3 minus 0 minus 0, and this will be 1 over 3. That implies that the limit is 1 over 3. The second example, we do the same thing. The highest value of x is s cubed, so we divide each time by s cubed. If we do that, we have the limit as x tends to infinity. Now, if you divide this by s cubed, you're going to have 4 left, plus 7x squared divided by s cubed, that will give you 7 over x, plus 5 over x cubed, divided by, here, this will leave you with 5 over x squared, plus 12 over x minus 6. Okay, substituting infinity, you observe that this is just a constant term, plus, if you substitute infinity here, 7 over infinity will give you 0, plus the 5 over infinity cubed, that will still give you 0, divided by, this will be 0, 5 over infinity squared, plus, here you're going to have 0 as well, then minus 6. To simplify this will give you minus 4 over 6, which equals to minus 2 over, minus 2 over 3. Alright, we move on to the next one. The limit as x tends to infinity of 4x cubed plus 3x squared plus 2 divided by x is power 4 plus 5x squared plus 1. So again, we look for the highest power of x here. Highest power of x that we have here is x is power 4. Divide each time by that, so that we have, this will become, look at this, 4x cubed divided by x is power 4. That will be 4 over x plus 3 over x squared plus 2 over x is power 4 divided by 1 plus 5 over x squared plus 1 over x is power 4. Okay, substituting infinity, you're going to have this to be 0 plus 0 plus 0 divided by 1 plus 0 plus 0, and this will be 0 over 1, which is still 0. So the limit is 0. Then the last one, the limit as x tends to infinity of x squared plus 1 over x plus 2. Okay, the highest power of x here is x squared, so that we have the limit as x tends to infinity of 1 plus 1 over x squared over 1 over x plus 2 over x squared. Substituting infinity, we're going to have 1 plus 0 over 0 plus 0, and we have 1 over 0, which is undefined. So that means undefined, that means the limit does not exist. Now, what we observe? We observe that if we have the limit as tends to infinity, and the limit is of the form infinity over infinity, the coefficient of the highest power of x will be the limit. Look at this. Highest power of x here is 1. Highest power of x squared is what? Is 2. So the limit of this one is 3 rather. The limit of this will be 1 over 3. Okay. So here, the highest power of x here is s cubed. Okay. The coefficient here is 4. Highest power is also s cubed. The coefficient is minus 6. So the limit will be 4 over minus 6. And if you simplify, you're going to get your minus 2 over 3. Now, if the highest power exists in the denominator, and it is not the same thing as the highest power in the numerator, then the limit will be 0. Ignore that. If the highest power exists in the denominator, and it is not the same thing as what we have in the denominator, okay? Highest power exists in the denominator, then the limit will be 0. But if the highest power exists in the numerator, okay, then it will be what? Undefined. The limit does not exist. So now, the next technique of finding limits is what we call the L'Hopital's rule, okay? But this requires the knowledge of differentiation before we can use. So I will add it to applications of differentiation, okay? Because it's one of the applications of differentiation. So to evaluate limits. So during our study of application of differentiation, we will treat the L'Hopital's rule of finding limits, and we apply that to limits of the form 0 over 0 as well as infinity over infinity. Thank you. We'll meet again.